Welcome to the SambaNova demo session. Here we will discuss SambaNova's platform built on a custom designed AI accelerator and a combined hardware and software system solution. As companies start to use AI within their domains, they are looking for platforms which offer several attributes. Clearly, industry leading performance is paramount, but it's also equally important to get accurate answers. Once you have accurate answers with the right performance, you need to be able to deploy them easily and at scale. Each of these attributes is multidimensional, and we will delve into them here. As SambaNova is a startup, let's start by understanding its founders. SambaNova was founded in 2017 by Rodrigo Liang, Kunle Olekatan, and Chris Ray with a vision of building a technology stack, inclusive of hardware and software, to intercept rapidly changing network models for training and inference, from data center to the edge, with the intention of expanding horizons of capability for the future of machine learning. Rodrigo Liang, the gentleman to the left, was Sun Oracle Senior Vice President of Processor Development. Rodrigo was responsible for Spark processor and ASIC development at Sun and then Oracle, and led the engineering organization responsible for consistently delivering 11 state of the art processors in 15 years with industry leading performance for enterprise servers. Kunle Olekatan, gentleman in the middle, is professor of electrical engineering and computer science at Stanford University. Kunle is known as father of multi-core processors, and his previous startup, Afara Web Systems, was the industry's first multi-core chip and was acquired by Sun in 2002. And this carried on into Sun's own Spark lineup under Rodrigo. Kunle is a pioneer of chip multiprocessor designs, director of Stanford Pervasive Parallelism Lab, and co-leader of Data Analytics for What's Next, or the DAWN research program. Chris Ray, gentleman to the right, is a MacArthur Award recipient, the industry recognized Genius Award, and affiliated with Statistical Machine Learning Group at Stanford, Pervasive Parallelism Lab, and the Stanford AI Lab. Kunle and Chris's highly recognized research stretches from working on domain-specific spatial language to weak supervision neural networks developed with very little label data, and encompasses areas of architecture, compilers, and algorithms, while Rodrigo's past work brings in expertise at the VLSI and architecture levels. Rodrigo's experience in VLSI and architecture, Kunle's industry leadership in architecture and compilers, and Chris's breakthrough work in compiler and ML frameworks provides SambaNova with a holistic architectural view that spans from algorithms to compilers to architecture to VLSI. AI is fundamentally a software problem and is trained by data rather than enormous amounts of meticulous coding, as is the case with traditional enterprise software. This implies not just extracting maximum parallelism among the nodes, but also being able to program data flow through these models. This is fundamentally a data flow architecture, and it is software driven. For SambaNova, this starts with a fully integrated stack that you see here that we call SambaFlow. SambaFlow software stack is designed to take your existing or new models and automatically optimize for the most efficient execution. This stack thus recognizes the compute and memory resources that are needed for these models and optimizes the layout to minimize communication, eliminate data latency for operations, and optimize network communication paths. The compilers now have a whole program view and can do immense amount of optimization on model execution, including pipelining, data and model parallelism, tiling, streaming, operator fusion, and many other things. With a self-contained software stack, there is no need to rewrite your proven PyTorch or TensorFlow models, or even understand our hardware architecture. Just recompile using our tools and experience high performance out of the box model performance. SambaNova SambaFlow thus eliminates months of learning, tuning, and hardware optimization to allow you to focus on what matters to you the most, your own application domain. SambaFlow SambaFlow's highly optimized models are accelerated by a custom AI accelerator. SambaNova designed the RDU, Reconfigurable Data Flow Unit, as the industry's next generation processor, and this is at the core of the SambaNova platform. This innovatively designed chip accelerates the execution defined by the SambaFlow compilation for maximum performance and energy efficiency. This chip is reconfigured specifically to optimize for every model execution. It keeps memory and compute close together to eliminate data latency and reduce off-chip communication, and executes maximum levels of parallelism in variable sizes. This flexibility gives it the ability to run very large memory models by having up to 1.5 terabytes of DDR memory attached to every chip, run efficiently both large batch size training as well as small batch size inference tasks, and remove any artificial design restrictions that have so far plagued model developers. Built with 7 nanometer TSMC technology, the RDU offers more than 300 teraflops of dense compute, more than 300 megabytes of on-chip memory, and incidentally 50 kilometers of wire to facilitate all the network switches that are needed for data flow programming. These innovations are wrapped in a package that consists of 8 of these RDU accelerator units and one x86 host, which acts as a central dispatch point for data and for programs. These nodes are offered in a data center ready rack that you see here, that is completely self-sufficient with a networking switch at the top, a terminal management switch, a console, etc., etc. Configurations come in upgradable form from a quarter rack, that is one node as I described it, with 8 accelerator units, half a rack with 2 of these nodes, or full rack, which is 4 of these nodes. You can also deploy multiple racks for large training examples. SambaNova data scale systems come in an easy to deploy rack that is otherwise fully standardized. The rack is standard, the form factor is standard, it's 42 RU, the power and PDU are standard off the shelf, cooling, it's air cooled front to back, operations are standard. Similarly, connectivity, open connectivity standards like Ethernet or PCIe Express or industry standard InfiniBand is supported in here as well. The host runs standard open source Linuxes, Red Hat, Ubuntu, and the stack accepts standard frameworks like PyTorch and TensorFlow. This allows us to deploy these systems quickly. Our customers have been able to bring these systems up within an hour from the time they are delivered, set up, and configured. They have been running acceptance tests at customer sites within the first hour. Now, SambaNova Data Scale System is our preferred infrastructure solution, the infrastructure rack that you previously saw. Architectural breakthroughs are of course great and necessary in this industry, given the constraints that model development is under. But companies also need solutions rather than just technology. So, at SambaNova, we have introduced an easy-to-use subscription service that we call Dataflow as a Service. Here we leverage our unique infrastructure solution as a subscription service with cloud consumption economics, ease of procurement, pay monthly rather than everything upfront, but it is fully managed by SambaNova behind your own firewall as a private cloud. These offerings come in 3 different flavors. There's the language flavor, there's the vision flavor, and then there's the recommender system flavor. In each, we bundle in models for that significant category. These models are pre-compiled, fully optimized, pre-trained with publicly available data sets with the assurance of world record performance and leading accuracy, convergence, and stability all built in, and with unmatched ease of use. So now with just a click of a button or an API, you can access these models directly. You can even retrain them with your own private data sets if you so desire. This transfer learning process is much faster and far less work than developing the model from the ground up. Now, imagine working with BERT without extensive software development and training resources, or being able to access GPT-3, the cutting-edge NLP model that requires months of development work and an enormous elaborate cluster setup. Similarly, on the vision side, with UNet models that can work with high resolution images, not just 224 by 224, but going 4K by 4K, 10K by 10K, or even in one case, we have 40K by 60K images. These aren't even remotely possible on other platforms. Similar with DLRM recommender systems that have terabytes and terabytes of embedding tables. SambaNova cuts down on months, sometimes even person years of engineering work to help you bring solutions to the market faster and tap into your AI advantage and leapfrog over your competition. Okay, so now you can see the benefit of Dataflow as a service offering and the solution ready platform that it provides for companies to accelerate their time to market. But we also often get asked the question, this is great technology, it's terrific innovation, but just how hard is it to actually program for this platform? How many PhDs do I really need to be able to tap into its impressive capabilities? Well, the answer is simple, not a whole lot. If you work with, let's say, PyTorch, then don't worry about CUDA programming or MKL optimizations for the platform. Just compile the application with our software stack with minor modifications, and the compiler and the analyzer will do all the work automatically to build you the best model execution. What follows here is a demo that shows this. My colleague will show how cutting edge Hugging Face transformer based NLP systems can be deployed with no change in code and within minutes. It's literally that simple. It's that easy. Let's go there now.
The Hugging Face repository shares the implementation of thousands of machine learning models. It is the most popular model repository for developing transformer-based deep learning apps. While Hugging Face greatly simplifies the front end of the development process, the compute requirement is still highly model and task dependent. Different processes still require different forms of compute infrastructure. With the integration of the Hugging Face library on SambaNova Datascale, our users can now freely exploit all the possibilities by simply using one repo on one platform. Thousands of models can be downloaded from the repository directly. With a single command line argument, any model can be easily run on Datascale in seconds, with no code change required. This allows data scientists to rapidly prototype and de-risk ideas without the cost of the overhead and human error risk of model reimplementation. The reliability of the results consequently also increases due to reduced human error risk. Next, I'd like to show you a demo of this integration. This demo walks through downloading one of the thousands of models from Hugging Face, loading it onto our Datascale system, and running a data point on the model. First, let's select the model and the task that we wanted to perform. Here, we're using Mini-LM for a task based on the corpus of linguistic acceptability. The model will be given a sentence and asked to decide whether it's grammatical. To emphasize, this code to download the model is standard and widely used. Now, we put it on our Datascale system with a function call. And that's it. We can run the model now. We can even use convenience functions from the Hugging Face library, such as prediction step. Here's an example from the dataset. Mary has always preferred lemons to limes. And the model correctly predicts this as grammatical. We can also try our own sentence. So book reads to John is ungrammatical, but John reads the book is grammatical. To highlight the flexibility of this framework, here's another task. This task, multi-genre natural language inference, takes two sentences, a premise and a hypothesis, and classifies their relationship. Let's see an example running on the Datascale system. So everyone's on vacation in August, and vacations are not allowed in August are contradictions. But everyone's on vacation in October is a neutral sentiment. If we now change this to nobody's on vacation in August, we see that the sentences entail each other. Finally, let's switch to a training demo. Let's select a task MRPC that converges quickly. We'll train it for 3 epochs and evaluate it every 10 steps. And there we go. Our model has successfully converged to an accuracy of around 0.88. To summarize, with the Hugging Face on Datascale integration, our users can now instantly run thousands of Hugging Face models with zero code change. That is, with state-of-the-art performance and accuracy out of the box, matching the best performing GPU for not just one task, but all tasks. So that's all for this demo. Thank you very much for watching.
Thanks for that wonderful demo. This is just one aspect of how we can reduce complexity by innovating within our stack. That cuts down weeks or even months of difficult model experimentation and development cycle. SambaNova's unique architecture also helps offer capabilities that are just not possible elsewhere, whether on a CPU or a GPU. So whether you are looking to train a model or just do inference, whether it's NLP or vision or recommender system, or even HPC applications that are sometimes called AI for science, those are also compellingly Dataflow applications. The SambaNova platform is the perfect place for your needs today and into future development. So come learn more about our many different proof points, our details on how this fresh new architectural approach is all set to change the world. And it's all set to make AI much more accessible for everyone, everywhere. Thank you.
Thanks, Vijay. We invite you to learn more about SambaNova's approach to next generation AI and how we help our customers offload AI complexity to speed time to insights. Visit our website, SambaNova.ai, and schedule a meeting with us to talk about how we can help you leverage your machine learning expertise to bring your AI applications into production faster and easier than you thought possible. Break through legacy technology bottlenecks and go from zero to innovation overnight with SambaNova. Thank you for your attention.